Okay, we will finish up chapter 9 with section 9.2. This will be pretty short. Okay, and this has to do with subroutines. Okay, and these are very, very similar to traps. And the idea is you have some code, here's your program. And you have a certain sequence of code, I'm going to write it over here, that you want to repeat over and over again. I'm just going to call this, X. And the idea is that what I want to do is at certain points in my program, I want to do X. And then at some point later on in my program again, I might want to do X. Something like that. So the intent here is that when I reach this thing, I come over here and I execute this. And when I get down to the last statement here, I come over here. And then when I get over here, I want to again come over here and execute this. But now this time when I return, I want to return there. And likewise over here, I want to come up here to X, and when I'm done, I want to come back down over here. So this is what a subroutine is. You should recognize this is very simple, similar to something in Java, something like a public static void, something sort of like a function. And the idea here is you do it with what's called a jump subroutine. So there's a JSR, and then there's a JSRR, okay? And these are very similar, and the only difference between the two of them is how far away the thing is that this code lives. Now, in all of them, there is an opcode of 0100. So this is also 0100. And then the difference is the following bit, okay? So the bit can either be let me see, I just want to make sure I don't make a mistake here. If it's JSR, it will be a 1. If it's JSRR, it's a 0. Okay, so if it is JSR, there is over here an 11-bit offset. Okay, and what this does is this is an 11-bit signed integer that would get added to the PC. Okay, so we should recognize this over here. This means that this can be plus or minus 1024 bytes or words away. Okay, any further than that, we would have to use a JSRR. Now for JSRR, there's a 00 here, then there is register, 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 and then there are 6 bits of zeros. So we realize this can specify any of the general purpose registers except R7, and we'll see why that's true in a second. So this can let us address all of the LC3 address space. Okay, so that's basically the big difference. It's a question of how far away this particular code is located. And again, the return mechanism is we basically do an RET. Okay, and remember that the RET is just a jump R7, which means that both of these save the contents of the program counter into R7 before they actually load the program counter. So in other words, we can imagine here, if I'm doing a JSR, okay, what a JSR is going to do is R7 is going to get the PC, and then the PC is going to get the PC plus the offset 11. The JSRR is R7 gets the PC, and then the PC gets whatever is in RRR, okay, the source register. Okay, the return mechanism for either one is very simple, that the PC just gets R7. Okay, and that's pretty much all there is to say. I'm going to say to you, read chapter 9.2, and that's all we have to say.